I'm not sure how this shows up in terms of other people's screens. It's good? All right, cool. Okay, so what we'll be very specifically doing today is we'll be dealing with some text data, and then we'll be getting them cleaned up a bit, dealing with some of the weird idiosyncrasies of data, and then getting them into two different fairly standard formats. Okay. So the first format is into a corpus format, and then the second is into a tidy text format. You do very different things with them. They're very different approaches and ways of conceiving of text as data. So I'm gonna sort of take you through the process of dealing with data and then getting them into those formats. So the data that I'm using for this are Amazon reviews. So let me show you what these look like. And these Amazon reviews are in a format called JSON. Let me bring this up real quick so you can see what these actually look like. Just a moment. Downloads. So you can see there we go. You can see what looks like a pretty horrible looking notepad, right? So the JSON format is actually very easy to use using computational methods. What you can see here is there's a curly bracket, then a field, and then an entry in the field. It's similar to a Python dictionary, if you're familiar with Python. The different fields can vary based on the JSON and where you're getting it from, but the format is very standardized. And it's very, very easy to parse and use. And if you are collecting data from an API, this is often what you will get. You'll get data that look somewhat like these. Normally, you can get JSONs that are just a single observation per file. This one is new line delimited, so each new line is its own JSON file. But there are fairly easy ways to read that in. So we are going to use the function from JSONLite in R called stream_in, and this just immediately loads it in. So let me run this, and we'll do that. And we can take a look at what this actually looks like. So the very beginning of these data, it reads in super easily. First column is the rating. Second column is an Amazon specific variable, which is if it's a verified purchase, the review time, etc. There's a bunch of data that are included in this. So let's see what it actually looks like in its data frame. So it's fairly clean. The JSON just very, very simply reads in as this. It has all these great columns, reviewer name, et cetera, et cetera. And then this is the one that we're really interested in, the review text. So this will give us all of the full text reviews. At the very beginning, some people are very unhappy with what they purchased. The summary is another sort of full text variable that we have here, but we're interested in the long form text. So a couple things about it. One is when we looked at this here, some of the time columns are actually pretty horrible. This is not a standard format. And then there's also a Unix time, a Unix review time, which is a standard format, but it's not really human interpretable because this represents the number of seconds that have passed since January 1st, 1970. So if you're just reading the numbers, it's not very meaningful, at least not to me. So we can make these a little easier to read. The other thing that I want to note about this is this review time variable. This is in a string. So a string is very hard to deal with dates because it's just characters. And that's just awful to deal with. So if we look at this class, it is a character vector. So we want it to not be that. So we're going to use the function from lubridate, which is part of tidyverse, month, day, year, because we can see here that this is month first, then day, then year. And this is just going to turn it into a, whoop. That's not right. There we go. All right, perfect. That will turn it into a date object, and it will reformat it into something much more standardized and easier to read. We also, one thing that's important about date objects is they're really easy to work with. So if you just add 1 to this, to the first date, it'll just add a day on, which is super nice if you're trying to do time lags or other types of data manipulation with it.
Real quick, Will,
Yes.
that MDY command, what are the limitations on what types of kind of spacing and characters it recognizes and is able to transform? Do you know?
I don't know off the top of my head. You can do fairly complicated things in lubridate as far as transforming things into date objects. And you can have it, you can effectively deal with it almost at a regular expression level. It's very, very useful for parsing characters and dates. But the really specific parts I don't remember.
Cool, thanks.
Dates are really terrible to deal with sometimes. So getting them into a date object is like from lubridate is super useful, especially at the very beginning. Other thing that was interesting about the Unix time, we could potentially get a time of day that these reviews happened at, maybe, because it's down to the second. However, once we actually look at it, this is only back to days, but sort of important note, this is still in seconds. So if we add 1 to the Unix time, it adds 1 second on. So they're fundamentally stored as different things, but they can still show the same type of data. So if we look again at these data, let's bring it back up. These don't seem to be organized in any way that's sensible. So what we're going to do is we are going to arrange it, and we're going to use it using a dplyr function called arrange. So we're going to redefine our reviews, which are stored as reviews, the reviews variable, and then use the arrange function, and then we're going to arrange it by date. This will give us a much easier to make of. And it will also let us see a couple weird things. So one, we can start to see that there are actually a fair amount of duplicates in this data frame. The way that, I don't know the really specifics of how this was created, but this data set was created as a fairly dense data set where each reviewer has reviewed at least 5 times and each object has been reviewed 5 times. So this could have just selected for things with weird duplicates. But because we organize this in a nice little way, we can pretty easily see that there's a bunch of duplicates in here and we can get rid of them. So we can do that with another little dplyr function called distinct. What this does is it looks for rows that are exact duplicates of other rows, and it just keeps one of them. So this got rid of most of the observations in this data set, but we still have enough to work on. Also, what was very useful about doing this, I'll bring this up again. One thing that's interesting about reviews that's really useful is they're usually pretty straightforward. What we can see from this is that not all of the reviews in this data set are super straightforward. We can see even from the very beginning of this, this reviewer had told part of their life story when they were talking about their dryer lint removing tool. Talked about their husband a lot and how he was incompetent. And so we can sort of see that we expect reviews to be fairly straightforward, but they're not always. So an important part about this is to make sure that we sort of validate these things at the very beginning. Sometimes people get weird with their reviews and they go off on weird tangents about torn labrums. So we can move forward. Now that we got rid of all of the duplicates, what we're going to want to do is we're going to want to create a unique document ID for each observation we have. What we're going to really want to do here is just keep track of what each individual observation is. And we can do this with this little line of code here. So the sequence length is going to give us a sequence of the length of the thing that we give it as an argument. So when we do this for the reviews data set, it goes up to 206, starting at 1. We can use this to create a column and just have it numbered from 1 to 206. We're going to be doing a corpus format first. So the corpus format has a few requirements. One of them is this document ID column, and it needs to be called doc ID. And then the second one is it needs to have the column with your text data in it needs to be labeled or named text. So if we look at the call names, we don't have that. It's review text. Just to confirm that, it is number 8. So we're going to rename this as text. They also need to be in specific spots for the corpus format. They need to be number 1 and 2. Doc ID needs to be first, text needs to be second. I like having date at the very beginning because it just makes it easy to read the data. And then everything else will come after. And this is another dplyr line of code here. And if you use the select function within dplyr, you just select doc ID is first, then text, then date, and then everything else is after. Other thing that I need to mention here is this is called a pipe. And then what this is doing is we're redefining reviews with reviews, and then this is all, the pipe is running the code within this data frame. So this is what the call names were before. We run this, and here is what they are after. Doc ID is first, then text, then date, then everything else. So we have the basics cleaned up. We got the date together. We got our doc ID first, then our text. Now we are going to put it in a corpus structure. The point of a corpus is to do document level work. what you care about are things like the word distributions across documents, or the frequencies of words in certain types of documents versus other types of documents. One of the sort of major things that you do with a corpus structure is you can use it to create a term document frequency matrix, or which is a representation of your data with rows as your observations, columns as particular words, and then you can see your observations as just a structure of the words that they contain and how many times that word appears. This is sort of the fundamental structure of the corpus. So we'll be doing this through the TM package, which stands for text mining. You can read a lot of different types of data into a corpus structure. You can do it directly from PDFs. You can do it directly from text files. This little get readers function right here will tell you what your options are. But you can also do it just directly from a data frame, which is what we'll be doing because we have one. So if we look at the corpus itself, there we go. I had to, yeah, that's terrible. If you can't see this, what's happening here is the corpus is a nested list of lists. If you try to interact with it in this way, it's really hard to actually see what's going on. But luckily, I'm going to close that. It has a lot of built-in ways to interact with it. You can really easily filter, print, stem, clean, all of these things that are very basic functions of dealing with text data. The corpus format is really easy to do things through. It also has a lot of metadata storage options that are super convenient and straightforward. And you can have metadata at the corpus level that is across all of your observations or documents, or at the individual document level, which is also nice. So the first way that you can do this is we can find the metadata of document 1 in our corpus. And if you look here, you can see that this is stored as a data frame, which is very nice. And it's just pulled directly from the data frame that we started with. You can tell R and the TM package to give you different sets or ranges. So if you just do meta your corpus 1 to 5, this will give you the first 5 records or documents that you have and all of their metadata. To access the text of the documents, you use the content argument, and make sure you use double brackets for this one. So to get the text for the first document, it prints out super easily. And you can do this for all of the documents in your corpus. And it's very simple to look at your data, think about them, and work through them in a corpus format. So now that we got it in there, we're gonna do 5 different things to sort of clean the data that we have. And these are all very standard operations to do on text data. The first thing that we'll do is we're gonna transform everything to lowercase. Cases of letters can be treated differently within computational sort of text analysis. Something with a capital letter, it looks different than something with a lowercase letter. So you want to just transform everything to lowercase, unless you're interested in uppercase, and then you have something more complicated on your hands. We'll strip out punctuation because that also increases the complexity of your text. And it's usually not helpful for you in processing and understanding your data. After that, we'll do stemming, which is removing the ends of words. When it's something like likes, it'll remove the S so that all of the words that are like based, like likes, liking, all of those are just grouped into one word instead of having all of these different variations of it. We'll remove extra white space because that can just muck things up. And then we'll remove numbers because numbers are hard to interpret at the document or corpus level. And all this is very, very simple to do in the TM package it across your corpus. So to transform everything to lowercase, we use the TM map function. We give it our corpus as the first argument. And then within this, we tell it to use the content transformer and then to lower. So just to reiterate what this initially looks like, lots of uppercase, we run this, and everything is now lowercase. It's very, very straightforward. You don't have to use any horrible regular expressions. You don't have to use G sub or anything like that. You just immediately and very simply and straightforwardly do this. And it does it to the whole corpus at once. To the 10th, to the 100th. They're all transformed at the same time. If you want to strip out punctuation, it works the same way. Use the same TM map, give it your corpus, and then remove punctuation. This will remove all of the punctuation that fits the regular expression punct form, and it just strips it all right out. And then stemming. So stemming, like I said, removes the ends of words. So this is what the text looks like here. We're going to stem it. And this is what it looks like now. Let's see. Ooh, that did not work correctly. That's weird. Huh. Well, that worked like 30 minutes ago. Well, I'll take a look into that later. What you would end up seeing is that the ear at the end of heavy would have been removed or should have been removed. Not sure why it wasn't.
Well,
yes.
I have a question about stemming.
Sure.
So I was wondering, so like many years ago, I tried to, do some text analysis, and yeah, I followed this the standard advice of stemming.
Mm-hmm.
But I recall running into some difficulties where, like you'll stem a word, and then the new word becomes like it's like how it will be like its own word. So I'm trying to think of an example. I can't right now, but like so for example, like your example with like it'll liking likes will get stripped down to I think LIK, and then but you can imagine a word where the stripped version is itself its own word. So imagine like LIK was its own word, and then you run into difficulties there, especially if it's an important word in your documents. So I guess a couple of questions. Well, I guess one question is there a way to kind of control the aggressiveness, or how much it stems words? And are there like different algorithms or different like things that different ways that people stem?
Yeah. So good question. There are many different ways to stem. And they vary in how aggressive they are. Some are really careful and don't actually change that much because that's sort of the intent of them. Some are extremely aggressive and will just like hack off words left and right. As far as how this affects the data analysis themselves, I think a lot of it comes down to when you do text analysis, there needs to be a lot of validation. And you need to look into how these steps are actually affecting the data at each step you take. So when you go through and you use one stemmer, it's really important to check and see what happens. Are are your results sensible? Are there these problems with these sorts of words being cut down? And then that actually causes problems. There needs to be a lot of validation as you sort of move forward. And that's just sort of a part of it. Text data can be messy, and it's just a problem that you have to deal with. But there are definitely other stemmers, and this, I think, uses a snowball stemmer, if I'm remembering right. But there's a number of them that you can use to do this.
Just to add
thanks.
to that, Will, what was I thinking? A lot of packages that have built-in stemmers and also software for analyzing text data in one library, like some of the Python software for it, they'll distinguish words that have been stemmed from words that haven't. And that kind of resolves the issue of changing their meaning. Like one of the common ways to do it is after you stem the word like, you'll get a tilde at the end like that. And that way you can tell whether it's a word that's been stemmed or whether it's a word that has its own meaning at the start.
Sorry, my internet pooped out on me for like 30 seconds there. So I missed what Scott said, but Mega's right. Some of this stuff did, in fact, get stemmed. I remember it being much more aggressive before, so that's what I was looking for. But it did turn out to work. The next step here is stripping white space. If you have a bunch of extra white space in your text, that can mess some things up, especially if you're trying to do more detailed text processing where you're using white space to figure out where words are or to find certain phrases. So it's a good idea to strip out extra white space. And then numbers. If you're particularly interested in numbers, obviously don't kill them off, but here we're really not. And then lastly, stop words. So stop words are really common words of a language that are hard to interpret. Words like for or a, and it's standard practice to get rid of them. This is a decision that you as a researcher have to make. Sometimes the stop words aren't distributed in a normal way across your documents. And if you remove them, you could be affecting some documents to a degree that other documents aren't. And it can sort of change how the language is structured and what the documents mean. Most people just get rid of them though, because they're just really hard to interpret. But it's a decision that you have to make and have to be aware of, that sometimes it will affect your data. So we get rid of the stop words, and there are standard dictionaries of stop words, and they exist for a lot of different languages, and you can just download them as a list or a vector and just use them from there. And then finally, now that we have all of that cleaned, we can make a document term matrix with this handy little argument or function called document term matrix. Then we just give it our corpus, and we can't really interact with it too much as that, but this is what it looks like. So this is a document term matrix. We have our documents here on the left, and then these are the stemmed words. So the way that the document term matrix is read, sort of by the computer and by the sort of methods that deal with this, is they read your document as it has ABL once, and then a lot of zeros, because the columns are every single word in your corpus. So they're tracked by the number of words that appear in that document, and then they're sort of compared to all of the words in the corpus total. So you can do a lot of things with this. those are sort of beyond the scope of where I want to go today because there wasn't that much time, but this gets you to a document term matrix, which is a really fundamental data structure to text analysis. Second, we are going to move to tidy text. So tidy text is a very, very different format. And the way that tidy text is organized is you have your document with your text in one column. This is done in a data frame format. Tidy text deals with your text in terms of tokens and the way that you tokenize something. And when I say tokens, I mean that you tell tidy text to read your text and then break it down into individual parts. A unigram token is 1 word per token. A bigram is 2 words per token. And you can tell tidy text to do these different things. And this is more useful for doing something like sentiment analysis, where you're really interested in the particular words. Whoop. Did I lose you? Okay, cool. I just got one of those internet unstable warnings. So this is really useful for word level sorts of analysis. All right, so I will get through this. So first, the tidy text is part of tidyverse, dplyr sort of universe. First thing that you do is you unnest tokens. There's a bunch of arguments to this function. First thing that we'll do is we'll give it the data frame that we start with, all the reviews. The second argument is the output column name. This will generate. The third is what we're pulling from, the column that has the text that we're turning into tokens. Here, we're telling it how to tokenize. So we're telling tidy text to tokenize at the individual word level. I'm very distracted by this cat who is adorable. And then at the same time, we're telling tidy text to just immediately turn everything into lowercase. So here is what a tidy text data frame looks like. What you will notice first is that we have a lot of docid1. That's because docid1 has a lot of words in it. So it creates a new row for every word. Then we scroll over a bit. And where did that go? Word. So this is the column that was just generated. Instead of having the entire text as one box, every single row is just one word, and then it just scrolls down. You could read the entire review by just reading down in a line. This is every word that was in that. So we can then quickly take a look at the most common words in our data frame. Let's scroll up a little bit. First things that pop out, bunch of numbers. Second, lots of what we would think of as stop words. And this is really showing why we get rid of stop words. The, I, and, to, a, none of these are really easily interpretable. So what we're going to want to do is we're going to want to get rid of those. So the way that you do that is a dplyr function called an anti-join. And as a part of tidy text, they have stop words built in. So we are just using this anti-join with this set of stop words, and that's just going to delete all of the rows that have a stop word in them. So we can go recheck what this looks like now that we got rid of the stop words. Much more interpretable. And scroll up. These make sense, and these start to actually kind of tell us what these data are about. They are about appliances. And so one of the more common ones that people were reviewing were dryers. There was a dryer parts was a big part of this. So people are talking about dryers, they're talking about vents, they're talking about lint, product time, drill. All of these actually start to make sense considering what the data are that we have. Getting rid of numbers in tidy text is actually a little bit more complicated. You have to use a kind of ugly regular expression and subsetting code to do it. I explain what's happening here. We don't quite have the time to go over it, but getting rid of numbers is a little bit more annoying. But we can do that. Get rid of that. This gets rid of all the numbers that were in the data frame. So this will get you to a fundamental tidy text, fairly clean structure. You have your data frame of all your observations and then your tokens, and you can start to do your analysis from there. If you want to do this with biograms, it's fairly easy to do. You just use the same function, data here. This again is the output column, the input column, and then you just tell it to do n-grams instead. Here, I have it do it by biograms. You can give it an arbitrary number. And let's just look at this just to show you what the biograms look like. Yep. There we go. Instead of everything being just one word, it's two words, and then it's a moving window that happens. So you go from this is a great. So it can do that with trigrams, 4 grams, 5 grams, arbitrarily high n. And then lastly, if you felt like getting saucy, you can split this column into multiple different columns so that you can deal with the different words individually, but you're sort of fundamentally working with biograms. And then from there, you can do your sentiment analysis or whatever you feel like. And that gets us exactly to 4. Yes.
Awesome.
Real quick, just before we wrap up, thank you, Will, for that great presentation. I also want to emphasize to everybody who is thinking about working with text data, definitely revisit this code. The packages Will introduced here are not only way easier to use than attempting to wrangle text data with base R, but much, much faster. The amount of processing Will was just showing would usually take a long time of worrying and produce a lot more errors. So definitely revisit this code if you have to clean up text data in the future.
Yeah, thanks a lot. I know we end at 4, so if anyone wants to leave right now, feel free to do so. But I did want to have a little bit of time if anyone had any questions about text analysis, the code that Will did. And I just want to let you all know that all the code is posted up on the GitHub page that I've linked in the chat. All right, take care, Jenna. Thanks for joining us. And it will also be posted up as a YouTube video for as an archive purpose. So what questions do folks have?
I had a question about the in general n-grams. Can you describe what purpose would you have for putting the data in that format?
So one potential thing that you'd be interested in are, if you're doing a sentiment analysis, you could be interested in shifter words. So words that change the meaning of the following word. So the classic example is not. So if you're just doing a unigram and you see cool, that would just be a positive thing. If it's described as not cool, that's a very different meaning, and that's something you want to capture in your analysis. So that's the type of thing that the n-grams can get at. You can also do more complex things with it, where you sort of look at distance and then the strength, if you're interested in particular topics within text. If you have a very broad sort of chunk of text and you're interested in one particular thing in there, you identify that thing, you can do the sentiment analysis where the sentiment word strength is a function of how far away it is from the sort of target. So the n-grams are things that you can use to get at that.
All right, that makes sense. Thanks.
I have a question. As someone who is just kind of picking up analysis stuff, what have you found better to work? So like you did this workshop in R today. What have you found better to work in R versus better in kind of Python languages for using this kind of data?
Personally, I'm just more familiar with R at this point than I am with Python. So I think that a lot of it comes down to that. Second, dplyr and the tidyverse stuff is very easy to work with. It's really straightforward. So that's another reason why I like it. And then third, things like tidy text and the corpus, those are developed because people work in R to do a lot of text analysis. So it's just fairly easy to do with the tools that are available to do it.
If I'll just jump in to echo what James is saying. There's plenty, text data analysis is one of those things where there's a ton of support in both R and Python. I think if you are looking at doing the kind of pre-packaged stuff that already exists in R in a package, then they can do similar things. But one of the advantages of Python is it has way better memory handling. And it's more, in my opinion, flexible for working with text data if you have to go outside of the library for anything. So I think it really just kind of depends on what the parameters of your project are going to be. If you're working with massive text data, then I would prefer Python because the memory demands get very, very big, very, very quickly, and Python's just better for that, where R isn't as good. But otherwise, for a lot of kind of pre-packaged, canned type of applications, I think you can really do it in either. And as James is pointing out, you can port some of the same packages that exist in R to Python as well. So there's ways to blend the two.
Yeah, R is painfully slow if you're dealing with larger data sets. So the original, this is a small chunk of the Amazon review data. Most of the full data sets from them are in the millions of documents. And I would never do that in R. That would just be horrible. You'd run code and then you'd just be sitting there for all day waiting for it. It would be terrible. And then also it depends. I think part of it also depends on your goals. If you want to do some sort of machine learning type of thing, then I would definitely do this in Python because the tools are much more natural to use in Python for that. And potentially more powerful because a lot of that development happens in Python and different fields, different groups work in different areas and different languages. And I think the machine learning stuff in Python is just better than in R. So it also depends on what your ultimate goals are.
Could you talk, Could you talk through some of how you actually interpret your findings? So the two different types of data frames you were showing us, but also then I know that on reviews, people can upvote them or like them. So is there a way to take into account which reviews are actually used more by other people?
Yeah, so the sort of intent of this is to get the data into a workable format, to get it into the corpus and document term matrix or into the tidy text format. So I wouldn't necessarily say that these data are done or sort of analyzed, but they're ready for that at this point. You can start to make meaning out of them and then use a topic model, for example, to start making sense of the text themselves or the sentiment analysis for the tidy text. So as they're more prepped to be cooked than they are cooked. They're still fairly raw ingredients.
Just to follow up on that, I think that's a great point, Meg. There's plenty of ways you could incorporate additional information to weight the scores that you get back from different types of text analysis. So you could do a sentiment analysis, which would return a numeric value for the positive or negative sentiment in a text. And then if you had additional information on how many likes a review got, you could do something like standardize or multiply each sentiment score by that value, and that would provide a weight for how influential it is. So a lot of it's going to be kind of context specific, but depending on the application, you could definitely find a way to do something like that.
Looks like we've kind of, someone want to go?
I have kind of a general question about text analysis. It's kind of a poorly formed question. So with text analysis, I've heard, I don't know what it is. So I guess my question is, what is this? Like I've heard of latent dirichlet allocation, like LDA analysis. I guess like it measures sentiment some way by using latent variables. But I don't really understand what it is. I was wondering if you have like an explain like on 5 2-sentence summary of like what it does.
I can take this unless Will or Todd's chomping at the bit here. So text analysis is just a strategy for taking unstructured text data and turning it into something interpretable or meaningful. So it's a broad way of talking about a diverse range of tactics. These range from very simple tactics like sentiment analysis, which is literally just counting the number of positive and negative words and assigning a relative value to them, to unstructured learning models like LDA or other topic models, which are based on clustering consistent words that appear together according to underlying topics. Or you can do to more advanced models like supervised machine learning, where you might be training data to detect what words, phrases, and combinations of words and phrases most strongly predict a particular category, and use that to assign labels to more unstructured text data. So there's a whole range of supervised, unsupervised, semi-supervised, and even non-machine learning methods to analyzing text data. And so part of the reason it's hard to get a finger on what it exactly is because it's just a broad field for taking unstructured text data, strings of characters, and turning it into something numeric and quantifiable and analyzable.
That was great. That was a great short summary. Thank you.
Well, awesome. This sounds like really great questions, really great presentation. Yeah, I think we can end it now. So thanks y'all for coming here. And in 2 weeks, we will be hosting a research brief with Grace and Kyle, and they'll be presenting some of their early stage of research, and I think we'll be all look forward to that. So I think for that, I'll send up a follow-up email maybe a week or so or a couple of days before the actual workshop itself. Just if there's any like readings or if there's any like brief one-pagers that the presenters want to send, I'll send those along. You don't have to review them, but I think it'll help create a more rich discussion where we kind of understand what folks are doing, so we could further help develop Grace and Kyle's papers a little bit more. So I hope everyone kind of enjoys a long weekend, and yeah, I'll see you all in 2 weeks.